This video is going to look at some of the natural processes that change your climate. We're going to look at volcanic eruptions, ocean currents, solar activity, and then the Earth's motions. A lot of this you should already be familiar with, but we'll just look at in a little bit more detail. So think about what happens when a volcano erupts. So your volcano, when it erupts, is going to have a ton of ash, a lot of gas, pyroclastic material that's going to go up into the sky. And then that's going to create a layer that actually blocks radiation, which we'll look at in the next slide. So do all volcanic eruptions, are they all violent? No. Remember, your shield eruption is very, very calm. It's the least explosive of them all. So based on that, you can think about when that layer of ash and dust is in the sky, if it's blocking solar radiation, then how will that affect your climate? What's going to make it a lot colder? So the presence of the ash and dust from eruptions will block and then reflect that solar radiation back into space. And that's going to cause your temperatures to cool drastically. And you can think about some other effects this is going to have, such as your plant life. Your plants are using solar radiation for photosynthesis. If that layer of ash and dust is blocking the radiation, then plants aren't going to be able to do photosynthesis, and that can cause severe famines around the world. There were many times in history where there were just huge amounts of people who ended up dying, and they say it's because of volcanic eruptions, not necessarily because the people were all close to the volcano, but because that volcano would trigger a famine that then would cause deaths worldwide. This is a video that you need to go on and watch. It's called A Year Without a Summer, and it talks about one of these volcanic eruptions that happened and wiped out almost half of the world's population. It's a short video, but please go back and watch it. Again, that link is in the PowerPoint. Ocean circulation. This is just looking at our ocean currents. We already know that warm currents pass by and make areas warmer, while your cold currents pass by and make other areas cooler. These two specific types of ocean currents we're going to look at is called El Niño and La Niña. El Niño and La Niña are opposites. I don't know how familiar some of you are with Spanish, but when you're looking at Spanish, El is going to be referring to masculine, like men, and La for women, which are opposites, and so that's kind of how you can keep that straight as far as this goes. So El Niño and La Niña are opposite phases of an ocean current. One will be very warm, one will be much cooler, and this is all occurring in the Pacific Ocean near the equator, and so that is the big deal to know on this particular slide. So let's look at El Niño and La Niña. El Niño is going to be when parts of the ocean current become warmer than usual. And so that's what you really need to focus on is El Niño equals warm. It's called the warm phase. So places that typically don't get much rain will get a lot of rain, and then certain places that don't get a lot of rain won't get as much. But El Niño is your warm phase, which makes La Niña your cold phase. And that also, again, is the big deal to know, just which one is warm and which one is cold. So La Niña is the cold phase. And this is cold because of upwelling. If you remember when we talked in the ocean currents unit, upwelling is when wind blows away part of the surface current of the ocean, causing your cooler, nutrient-dense water to come up. So La Niña is going to be very good for your fishermen. And so what I want you to look at right now is these pictures. Notice that there is a big blue and purple line around the equator here. That's the La Niña. That's showing the temperature of the water. And notice in El Niño, it's turned red. El Niño warm, La Niña cold. And there is a video that you can watch. If you click La Niña, it is a link, and it just it explains a little bit more of why this happens and shows you a visual of it. So please watch that. Solar activity. This is just talking about our solar radiation. We know solar radiation gives us day. We know that because the Earth is tilted, it will give us seasons. But there's something else that solar radiation does, and that is it creates these things called hot spots. Hot spots are actually colder places on the sun, ironically, but they are associated with the giant solar flares. If you think back to the unit 7, we talked about how solar flares, when they come to the Earth, there is a force that protects us from them, and that is called the magnetic shield. That magnetic shield is generated from the core of the Earth that goes through the core, through the mantle, through the crust, out past the atmosphere, into outer space, circles around, it absorbs these solar flares, and then gives us, as a result, the northern lights, which are extremely beautiful. But these particular solar flares that we're looking at, that there isn't much known about them because it's very hard to study the surfaces of the sun, as you can imagine. But solar flares are tend to be corresponded with warmer periods in Europe and North America. And that's really the big thing to know. So they don't know if that happens for sure, but that is what scientists are thinking, is that when we look at hot spots, typically North America and Europe are a little bit warmer. And so they think that might be a cause for it. It's not well known, but that is what they are thinking. So just be familiar with that from this slide. So the Earth's motions. We learned about a bunch of different motions the Earth does in Unit 2. Rotation gives us day and night. Revolution marks a year. Your barycentric motion is for two things orbiting each other, like the moon and the Earth, or the Earth and the sun. You have precession, which is a change of direction with your Earth's axis, and then you have nutation, and that occurs during precession, where it's the wobble or oscillatory movement of the Earth's axis. But this is just looking at the Earth's tilt giving us seasons. And so we already know that the Earth's tilt gives us seasons, but make sure you do remember that. And if you need to review any of those motions, that is from Unit 2. A couple other things that can change your climate is our carbon dioxide fluctuations. So carbon dioxide amounts are not always steady throughout the atmosphere. They actually are a lot lower with the coronavirus going on because so many people are quarantined. They're not driving as much, and your factories aren't producing quite the same amount as what they were. So our pollution levels, with everybody kind of taking a break from things, have gone way down, which is actually very interesting. But other things that can cause carbon dioxide fluctuations is your growing seasons. So remember, plants breathe in carbon dioxide and they breathe out oxygen, so they replace it. And so when you have spring and summer, when plants are in bloom and new things are growing, your carbon dioxide levels are actually lower and oxygen levels are higher. And then in the winter and fall, when there aren't as many plants, your carbon dioxide levels go up and your oxygen go a little bit down. And you can see that in this graph down here. Every time they shoot up, that's going to be your spring or summer, and when they drop down drastically, that's going to be a fall or a winter. Carbon dioxide, as many of you already know, is a greenhouse gas. So now we're going to look at what the greenhouse effect is. So the greenhouse effect, I just want to throw this out here, it is a good and natural thing. So your greenhouse effect is good and it's natural. Greenhouse effect is not man-made, and it's not bad. If we did not have the greenhouse effect, we would not be alive. Temperatures everywhere would be at least 100 degrees colder, okay? So the greenhouse effect is a good thing. Your greenhouse gas, such as carbon dioxide, it helps to trap heat from the sun and warm up our lower atmosphere. Again, think about it when it was 30 degrees this winter. Imagine it being 100 degrees colder than that. Okay, we want there to be heat trapped in the earth. So it traps the solar radiation. Your main gases are carbon dioxide, methane, and water vapor. And you need to know all three of those. Carbon dioxide is the greenhouse gas that humans most give out, contributing to the greenhouse effect. Methane, however, is the strongest of them. So it's going to have the biggest effect. And then water vapor is the most abundant. So I'm just going to write lots. So there's more water vapor than any other one in the lower atmosphere. However, we aren't very concerned with the water vapor because it is cycled in and out due to the water cycle. So we don't talk about the water vapor because it's not posing a problem, although it is a part of the greenhouse effect. But it is the most abundant in the lower atmosphere. Methane is the strongest, but carbon dioxide is the one that people most give out, and that's why it gets the most attention when we talk about global warming. But what you need to know is greenhouse effect and global warming are not the same thing. The greenhouse effect is good and it's natural. We have to have it. Global warming, however, is when we have too many greenhouse gases. If we did not have the greenhouse effect, the earth wouldn't be warm enough for us. So that would be bad. But too much of anything can become a bad thing. So that would be like, say you are in your house. You know, we have the heat on. The heat is good. We like the heat to warm up our home. But if you stay in your house and then you turn your heat up to 90 degrees, all of a sudden you have too much of a good thing, and now your house is too hot and unbearable. This happened to us one time. I was a teaching fellow at East Carolina, and we went on a trip to New York. Well, we were riding a bus there and back, and on the way back from New York, the heat got stuck on, and it got stuck on high. And so for hours, the heat was running, and we were all trapped in a charter bus where no one could roll the windows down. And so they actually had to pull the bus over so we could get out and stand on the side of the highway so people wouldn't overheat. And that was an absolutely miserable time, but that's just another example of too much of a good thing can become bad, and that's what global warming is. Too many greenhouse gases. The greenhouse gases are good, but once we start pumping out too many of them, the earth begins to get too warm. And over the past 50 years, the average temperatures have increased at a faster rate than any other time in history. Now, a lot of people will tell you, well, the Earth's temperatures are always going up and down. It's nothing to worry about. It is not that the temperatures are changing that's a big deal. It is the rate of the change. People talk about how the Earth has always adapted and will continue to adapt. However, adaptations take an extremely long time to form. So if you have a change in environment very quickly, then the Earth can't adapt because it doesn't give it enough time. And that's what the big issue is with global warming. Couple things that can cause it is burning too many fossil fuels. Remember, fossil fuels are traditional energy, which is coal, oil, and natural gas. Burning all of them releases carbon dioxide. And if you remember back to Unit 7, coal is the dirtiest of all the fossil fuels, while gas is the cleanest burning. But that is the largest source of the pollution that traps or releases a bunch of greenhouse gases. A couple of effects that global warming can have is rising sea levels. Global warming means the Earth is becoming warmer, which can cause the ice caps to melt. And if the ice caps melt, that will make the ocean deeper. That's what we get, rising sea levels. It will also disrupt your habitats, such as coral reefs. Warming of the ocean can cause the temperatures. If you remember back when we talked about different pollutions, your aquatic species are very sensitive to temperature. So if you change your temperatures even by 1 degree, it can throw off a lot of aquatic species. And that's what we see happening with your coral reefs. It can also cause a longer allergy season. So any of you who have allergies, it promotes a longer growing season. So this is where it would not be so fun for you. And it can cause changes in our weather patterns, which can also have big effects worldwide. And this is the last slide, but if Antarctica melted, it's just showing you that our oceans would rise at least 220 feet. And this is just showing you, if that happened, what it would look like. And as you can see, like down here, all of Florida would be underwater. And you've got some major cities like New York and Boston that would all be underwater. And if you would like, you can go back and watch this video on Antarctica melting. That is a link. You can watch it and it'll just show you some of those things that it would create. However, when we're looking at this, we're talking about many years from now, so not within our lifetime. But that is it for natural things that change our climate, and that is all for our video. And that's it for this unit.